Hi everyone. This lesson is going to be about calculating Pearson's correlation coefficient, also known as R. So I've got an example of a question here that we might have to do. The following bivariate data was recorded. So bivariate just means two variables, x and y. Then calculate the correlation coefficient. Justify your answer with mathematical reasoning. So the first thing I'm going to do is take a look at the formula sheet. So this is my correlation coefficient, also known as R, and there's the formula. The formula it's a bit diabolical, but we'll get there if we break it down. So let's start. We have 1 over n take 1. So the first thing I'll note is n. N is the number of data pairs. So basically the number of rows in the table here. There are 5 rows. Then this great big sigma sign means the summation. We have xi. Xi is just each of the individual values in turn. X bar is the mean. Y bar is the mean of the y's. And Sx and Sy are the sample standard deviations. Now we can use our calculator to help us with some of these things. So the first thing I'm going to do is put my calculator into stats mode. And not like we did in grade 11 with one variable, I'll use option 2 here, a plus bx, because this is going to give me x and y. So I have to enter my data here, so bear with me for a moment while I do this. Now if I head to the top of the y column, I'll enter the y values. Well, that wouldn't have helped, would it? And 90. Notice that the column here for frequency defaults to 1. That's exactly what we need. Each of these data points appears only once in our list, in our table, and that's usually the way it is. Once we have the data entered, I just hit all clear. That just clears the screen. It doesn't delete the data from memory. Now, notice in this formula I need things like the mean of the x's and the mean of the y's. So to calculate the mean of the x's, I need the sum of the individual x's divided by n. And this is what it means by justify with working. So I'll just write the mean of the x's is the sum of the scores, x, divided by n. Now, to show my working here, I could add the x's in that column, or I could use the stats menu. One of these options here, number 3, is for sums, and sum of the x's is 2. It's 20. And there were 5 data points, and 20 divided by 5 is 4. The mean of the x's is 4. The mean of the y's, it'll be the sum of the y values divided by n. Again, I could just add the numbers in the table, or I could go into option 3 for sum. Now sum of the y's is number 4, and that's 400. And 400 divided by 5 is 80. If you think 40 divided by 5 is 8, and there's an extra 0. So we've calculated this number and this number. We still need the standard deviation of the x's and the standard deviation of the y's. Now, because the focus of the question is correlation coefficient, I'm not going to use this formula. I'm simply going to use the calculator to find the standard deviation of the x's and the standard deviation of the y's. And I'll write that number down, because the standard deviation calculation itself is a reasonably complicated calculation. Once again, into stats. This time, variables here, 4. There it is. Sx is option 4, and Sy. Be careful not to use the sigma one, it's the S. So 4, and that's 1.5811. It's always worth keeping quite a few decimal places when you do these, so we don't introduce rounding errors. And the standard deviation of the y's is this one, Sy, option 7, and that's 15.811 4 if I round. So I've now calculated also that number and that number. And I already knew n, I just counted them up. The thing that I have to do now is start to do the rest of what this formula says. And the way I need to do that is by completing the rest of this table. The thing at the top here says each of the individual x values subtract the mean of the x's. So I'll write this as my heading. xi take the mean of the x's. Remembering the mean of the x's is 4. So in the first one I have 2 subtract 4, that's negative 2. Then I have 3 subtract 4, that's negative 1. 4 subtract 4 is nothing. 5 subtract 4 is 1, and 6 take 4 is 2. Now I have to do y, each individual y value. That's a mistake, I should have written the mean of the y's there. And that comes from the top of the second part in the formula. Remember the y mean was 80. So 60 subtract 80 is negative 20. 80 take 80 is nothing. 70 subtract 80 is negative 10. 100 take 80 is 20. And 90 take 80 is 10. Now this formula requires that we multiply we call these the deviations. So the x deviations multiplied by the y deviations. So that's why I've got this column here. xi take the mean multiplied by yi take the mean of the y's. Negative 2 by negative 20 is positive 40. Minus 1 by 0 is 0. 0 by negative 10 is 0. 1 times 20 is 20. And 2 times 10 is 20. I'm almost there. Now I'm going to write down that formula for Pearson's correlation coefficient. 1 over n take 1, the sum of xi minus the mean of the x's, yi take the mean of the y's, and divide by sx by sy. Now because I know it looks like these standard deviations are in brackets, but it actually still works if I write it this way because the s's are constants. So let's put my numbers in place. N was 5. Now this giant thing here, the summation of those. The summation of those is if I add all of the numbers in this last column. So adding those all together, I get 80. That's the number that goes on the top. The sigma at the front means to add each of those. Now what was my sx value? That was 1.5811 and sy was 15.8114. So let's get the calculator back and we'll work that out. Now I'm still in stats mode, so things aren't going to look quite the same as normal when I do stats mode. So if I go 1 over 4 in stats mode, it puts this funny little symbol here for the fraction. I might just use brackets on that to be absolutely sure that the 1 over 4 is a standalone entity. And now I've got 80 over, and again I'll use brackets on the denominator, 1.5811 by 15.8114. And there's my Pearson's correlation coefficient. Very close, well, pretty much exactly 0.8. If I go to 3 decimal places, it's 800. Now, that's using mathematical justification. So we've done all the working. The alternative, if you didn't need to justify, if it was a 1-mark question and you only needed to give the answer, then you would have done the same as I did. You would have entered the x and the y's into here, and then under the stats menu, under regression, you would go straight to option 3 and look at that. That's the exact answer that we produced. So if it was just a 1-mark question where we only need the answer, you can use the calculator to give you the value of r. If you need justification, if the question specifies justify your answer with mathematical reasoning, then you have no choice, I'm afraid. You have to do all this working and quote this formula, which we've got down here. Okay then, hope that helped. Thanks for watching.